What up, party people? Mr. Harris again. And we are back. If you're watching this live, you happen to just jump on your phone or your computer and you see me live on YouTube right now. Say what up in the comments. Drop a one, a two, a math symbol, something. But anyway, because I'm doing this live for my students in my classroom, I'm gonna get right to the information. Do me a favor, like, share, and subscribe to the channel. I'm gonna keep dropping. I'm back. I'm back on the roll, and I'm enjoying this process again. So, for the students watching this live or watching the replay, we are in Unit 5, and we are doing Lesson 12. Now, this was gonna be short because I'm only doing two main activities from Lesson 12, and so let's get right to it. So we're starting on activity 3, which is page 123. And I'm going to share my screen. I cannot share that right there. Let's get this straight real quick. Y'all give me a second. Let's see, what am I trying to share? Exit out of that. Go to this one. Nope, that's not it. Go to this one. But that's not it. Where did he go, George? Where did he go? You know what, y'all? I didn't. Oh, there we go. There we go. Share the screen. So, we want to present this. Present. Boom. Hopefully, they'll let me write on this. They will. As you can see, we're talking about interpreting, creating graphs, and comparing the graphs as well. So now this unit is about functions. So if you're not one of my students and you're watching this, first of all, I appreciate you from the bottom of my heart. And we are talking about functions. So this unit is on functions. So let's look at activity 3. We're talking about population growth. Notice it says this graph shows the population of Baltimore and Cleveland in the 20th century. So B of T is the population for Baltimore in year T. C of T is the population for Cleveland in year T. And as you can see, we have a graph. The blue solid line represents the city of Baltimore, and the orange dashed line represents the city of Cleveland. For those of y'all that don't know, Baltimore is in Maryland and Cleveland is Ohio. Hopefully you visited those places. I've been to Baltimore, was there last week, but never been to Cleveland. I drove through it, but that's about it. But you know, that's where, ain't that where Brian from? Or something like that. Anyway, number 1, we want to estimate B of 1930. B meaning we're talking about the city of Baltimore. I think I'm going to go with green and night. And so we want B of 1930. So we're going to look at the year, which is on the x-axis. So that means that's our independent variable or our input, okay? So we're going to find 1930 because it has 1930 as our input. So where on the x-axis is 1930? It's about right here. So we're going to go up and we are talking about B, our output, so Baltimore. Notice the blue line is Baltimore, so we're going to go up from 1930 and we're going to land right there. All right. And if we look to the left on the y-axis, I hope I said x-axis when I said 1930. So, and notice it is 800,000. So 800,000, right? So what does that mean? It says estimate B of 30. So B of 30, I'm sorry, 1930. It equals 800,000. What does this mean, Mr. Harris? This means that, I'm going to type this one today. I'm going to be a little neat. So this means, let's stretch this out. This means the population of Baltimore in 1930 was 800,000. And that's it. That's all that means. All right. So you've got it. And we can go on to part B of this. So let's clear it out. Boom. Let's exit out of this. And I got a slideshow tonight, so I ain't got to keep going back and forth. Oh, wait. Hold up, player. Hold up, player. Go to the next. Oh, wait. We want to go that way. All right. Here we go. Part 2, number 2, rather. It says this graph shows, so same thing. I don't have to read that to you again, but the question says, here are pairs of statements about the two populations. All right. In each pair, which statement is true? And you want to be able to explain how you know. So when I look at the first pair, let's pull up that green again. So this is the first pair. And then it says, or this second pair. All right, so B of 2000. So we're going to go Baltimore for B. That's our output. Our input is 2000. Once again, output. I don't know why my handwriting is kind of ugly tonight. And input is 2000. So let's go to the year 2000. It's right about there on the x-axis. And we see that for the city of Baltimore, which is the blue line, for 2000, this is right there. Now, let's go to the left. If you can see the cursor, hopefully, you see it's a little bit above 600,000. So let's estimate that. Well, we don't necessarily need to estimate that. Actually, if we just look here, Baltimore is higher than Cleveland. So Baltimore is here. So B of 2000 and C of 2000. So now let's go back to this statement. Is B of 2000 greater than C of 2000? As we can see, the blue line is higher than the orange dotted orange dash line at 2000 for the input of 2000. So we're going to say that this is true. All right, so this is true, that B of 2000 is greater than C of 2000. All right, so this is true. All right, let's go over to the second one. It says B of 2000 is less than C of 2000. Well, these two cannot be true at the same time. So we've already said that the population of Baltimore is greater than the population of Cleveland in 2000. So this would be false. All right, and the question only asks us, it says, which statement is true? So we've determined that the population of Baltimore in 2000 is greater than the population of Cleveland in 2000. Now, let's look at the second one. Notice this one has an equal sign. Once again, we got input of 1900. We got output of the city of Baltimore. My phone is ringing and I can't talk right now, homie. I'll holler at you later, player. And it says, or the population of Baltimore. So once again, this is input. This is for the first one. And this is output. Okay. Still, I don't know why my handwriting is not good. And then over here we have the statement Baltimore. The population of Baltimore in 1900 was greater than the population of Cleveland in 1900. So let's look at 1900. Now, we're going to erase some of this stuff that we had up here already. Y'all probably like, Mr. Harris, you kind of hyped tonight. And I am. Andy is. Okay, I am. I got a little more energy than I've had the last couple nights of doing these. So let's look at the input of 1900. Boom, we go back to look at that. That is 1900 is on the y-axis, okay? So let's see what happens. The population of Baltimore in 1900 is equal to the population of Cleveland in 1900. Well, if they were equal, then the y-intercept of both of these would be at the same spot. As we can see, the Baltimore population in 1900 was actually higher than the Cleveland population in 1900. So this first statement is false. All right, let's put a box around that so you know that this is separate from this one over here. Let's put a oval around this one. So now let's check the other one. We're going to erase that. We're still at 1900. So let's look at 1900. The population of Baltimore in 1900 is greater than the population of Cleveland in 1900. Okay, so Baltimore, the blue line, once again, it is higher than the population of Cleveland. So this is true. All right, so notice in this, we are given a certain input, which is in parentheses. Okay, and then we're going to go to whatever that input value is. In question A, it was 2000. In question B, it was 1900. And then when we look at that and we just see which one is higher on the graph for the output value. So technically, if we want to know, let's go a little deeper, right? So we know these are true, or this second one is true compared to the first one. But let's say if I want to say, well, Mr. Harris, well, what is the population of Baltimore in 2000? So we're going to do this one. The population of Baltimore in 2000 is halfway between 400,000 and 600,000. So it was 500,000, okay? Because we need to know the output. The population of Cleveland in 1900 is right there. I would say 399,000. 399,000. And let's erase this little dot just so we could tell. Okay, so it's slightly below. But if you were to say it's 400,000, that's totally fine. It's obvious that the population of Baltimore is higher than Cleveland in the year 1900. All right. Remember, don't forget to pause, rewind, fast forward, or whatever, so you can ask questions and things like that if you have questions. All right. So now, let's go next. Where's mine? Let's see. We're going to go to the next one. Question 3, or tree as I like to say. Question number 3. What does it say? It says, were the two cities' populations ever the same? If so, when? Now, in a question like this, we want to see where these two functions, where the graph of the function intersect. That means they cross paths, right? So notice they cross paths at this point. Let's erase this other dot right here. They cross paths at this point right here. And they cross paths at this point right here. So the question is, since they cross paths, that means they were at the same, they have the same output. So the question's answer is yes. And it says when. Well, boom, at this first green dot, what is the input value there? That would be 1910. And then here we got to estimate it a little bit because it goes right down. So it's somewhere between 1940 and 1950. It's not directly in the middle of 1940 and 1950. So I'm going to say about 1943. All right. So notice whenever you want to know, is the output value the same, we want to look at where these two functions, the graph of these functions cross or intersect. Okay. And that's that. This is activity 3. All right. So we're still lesson 12. That's activity 3. Let's clear all those and say, let's go on. All right, so take that annotation off, get my handy dandy mouse back. Activity 5. So now we skip it over to page 126. All right, same thing, but notice we have two different functions. It says here are graphs that represent two functions, function f and function g. Be very attentive to what you see on the graph. One of the things that I noticed, we talk about notice and wonders as a learning routine a lot of times, but what I notice is that there's no label for the input and there's no label for the output. So output, boom, input, boom. So we have no label. We don't need that in this case. So it says decide which function value is greater for each given input. Okay. So in the first one, let's change up the color, man. Let's go back to that good old red. I would use blue because it's my favorite color, but I have a blue graph on function G. So notice the blue line is function G. The black line or black curve is function F. We'll talk about what that curve is in the next unit or in the unit to come down. So we're looking at an input. Let's do this. Let's go back. So input, remember it's in parentheses. So input, that's not cute. It's an input of 2. All right. So f of 2, so it says which function value is greater for the given input. All right. Notice all of these have the same input on each question. So when I'm looking at the input of 2, we're on the x-axis. Boom, 2. So now when I look up here, which one of these is higher? Okay, I have the function f but then I also have function G is higher, okay? So G of 2 would be the solution for this one, because as you can see, G of 2 has an output of 7.5, and F of 2 has an output of 4. So G of 2 is higher, okay? Let's erase this now, because I don't want to confuse y'all. And let's erase that dot. Now, part B says F of 4 or G of 4. We're still trying to find out which one is higher. Let's go to the input of 4. And notice when I get to 4, bing, they are the same because they intersect at that point. So which one is higher? We could say they are equal. Okay, so we can write a statement that says F of 4 is equal to G of 4. Okay. So that's that. Boom. All right. C. F of 6 or G of 6. We're at the input of 6 now. Notice when I look up at 6, boom. G of X is lower than F of X. All right. So we're looking for the one that's higher. So F of X is higher. We see that from this point right here. The output of F of X, I'm sorry, the output of F of 6 is 8, right? Look at that 8 right there. The output of G of 6 is about 6.5, okay? So F of 6 equals 8. G of 6 equals 6.5. All right, so once again, F of 6 is higher. And now, last but not least, let's erase all this. All right, and we're going to look at the input of 8. The input of 8. All right, so boom, right there. Let's go up. Which one is lower? Or the question asks which one is higher. But we can see G of X is about 6. So G of 6, I'm sorry, G of 8 equals 6. F of 8 equals right here, and that is 7. Okay, so which one is higher? F of 8. Okay, F of 8 is higher. All right, I think that is actually, nope, there's a little more. There's a little more. There's a little more. Take this, pause it if you need to. Let's see. Cancel that. With my handy dandy. Okay. We got 2 more questions here. Okay. And let's answer those questions. So it says that there a value of X for which the equation, where's my cursor? All right. Is there a value of X for which the equation F of X is equal to G of X is true? Boom. It's right there for the input 4. So when X equals 4, and there's another point over here where they intersect when X equals 9. And you want to explain your reasoning. So if we explain it, then it's because when X equals 4 and when X equals 4, the graphs intersect. And when X equals 9, the graphs intersect. All right, so that is when they are equal. Okay, now for those 2 different things, the output of F of X and G of X is the same when X equals 4, and the output for F of X and G of X is the same when X equals 9. However, when the input is 4, the value is 7. When the input is 9, the output is about 5.8, 5.9. All right, so be very, very mindful of those things. Let's clear this out. And last but not least, question 3, it says identify at least 2 values for which the inequality F of X is less than G of X. All right, so we're looking for F, the black line or the black curve, which is called a parabola. is lower, okay? So at least two values, all right? So we can do more than two. For when f of x is less than g of x. So we want to look at where on this graph is x lower, is f of x lower than g of x? And let me tell you something. Let's do this. Let's make a thicker line. So from here, all these points right here, f of x is lower than g of x. Now, we're going to stop right before they intersect, because when they intersect, they're equal. And then over here, we're going to start right under where they intersect to where f of x is lower, okay? So what we're going to say is we can use this input, this input, this input, but we don't want to say 4 because they are the same at 4. We don't want to say 9 because they are the same at 9, but we could say 10, we could say 11, and it doesn't go all the way to 12. But if it did continue, it would be lower at 12. So we could say x equals 1, x equals 2, x equals 3, x equals 10, and x, all right, come on now, equals 11, okay? So for all of those 5 values, f of x is lower than g of x. Now, I'm going to add a little bit to this, and you might want to say, well, Mr. Harris, well, when is f of x greater than g of x, okay? So in these areas right here, now this is totally separate from this question, okay? So please don't be confused. So let's erase this because I don't want to confuse y'all. In this section up here, from not 9, but just above 9, all the way through, just above 4, and all the way up right before 9. In these areas, f of x is greater than g of x, okay? So, when we're going to say, let's write this as an inequality because I want y'all to see it. 4 is less than, so that doesn't include 4, x, and that's less than 9 because we don't want to include 4 and 9. But anywhere between 4 and 9, f of x is greater than g of x. I hope this has been helpful. Let's clear it out and let's wrap this up. One of the things that you want to be able to do is look at the graph, and you have 2 functions on the same graph, and you want to see places where one of the graphs is lower than the other graph, one of the graphs is higher than the other graph, and the points where they intersect, because that means they have the same output. And you want to be able to identify these things when given different, more than one graph. Sometimes it could be more than 2. It could be 3, 4, however many, but you want to be able to identify these different parts of the graph. I hope this has been helpful. Remember, if you have any questions, you can type it in the comments. You can send me a message for my students on Canvas. You can also ask those questions in class. If you're watching this and you're not a student of mine, but you happen to come across this video, then by all means, send me a message, or you can type your question in the comments. I do respond to all the questions. I appreciate the feedback. Thank you. Remember to like, share, subscribe. Share this with one of the homies, one of the parent homies, one of the student homies, and all that. All right. Thank you so much. Remember, I don't have a great quote right now. Remember this: anyone can do mathematics, right? But it starts with the mindset and the belief that you can do mathematics. Y'all have a wonderful evening.